Question 2, Part D. A skydiver jumps from a hot air balloon which is 2,000 meters above the ground. The velocity, v meters per second, at which he is falling t seconds after jumping is given by v equals 50 times 1 minus e to the power of negative 0.2t in brackets. Part 1. Find her acceleration 10 seconds after she jumps. Give your answer correct to 1 decimal place. The acceleration a is found by differentiating the velocity equation with respect to t. So given that v is equal to 50 times 1 minus e to the power of negative 0.2t in brackets, we can make the differentiation a little easier if we expand the brackets first. So v is equal to 50 minus 50 times e to the power of negative 0.2t. Now the derivative of 50, being a constant of course, is 0. So we only need to differentiate negative 50 e to the power of negative 0.2t, and we can use the chain rule for that. Hence, dv dt is equal to negative 50 times e to the power of negative 0.2t times the derivative of the index, which is negative 0.2t, and that equals 10 times e to the power of negative 0.2t. Now, at time t equals 10 seconds, the acceleration at the 10-second mark, a of 10, is equal to 10 times e to the power of negative 0.2 times 10, which equals 1.35335 and so on, which rounds to 1.4 meters per second, correct to 1 decimal place. Part 2. Find the distance that she has fallen in the first 10 seconds. Give your answer correct to the nearest meter. The distance fallen, x meters after t seconds, is given by x of t is equal to the integral from 0 to t of the velocity equation v dt, which equals the integral from 0 to t of 50 times 1 minus e to the power of negative 0.2t in brackets dt. Now we can expand the brackets like we did in part 1 to make the integration a little easier. So when t is equal to 10, x of 10 is equal to the integral from 0 to 10 of 50 minus 50 times e to the power of negative 0.2t dt. And that equals 50t minus 50 times e to the power of negative 0.2t divided by the derivative of the index, which is negative 0.2. And the limits of integration are from 0 to 10. We can simplify what's inside the square brackets here a little further, especially this fraction term here, and that equals 50t plus 250 times e to the power of negative 0.2t from t equals 0 to t equals 10. Applying the limits of integration, we get 50 times 10 plus 250 times e to the power of negative 0.2 times 10 in brackets minus 50 times 0 plus 250 times e to the power of negative 0.2 times 0 in brackets. Now 50 times 0 is 0 and e to the power of 0 is 1, so we get 250 here, and 50 times 10 is 500, so this expression here is 500 plus 250 times e to the power of negative 2 minus 250, which equals 283.8338 and so on meters. And that equals 284 meters, correct to the nearest meter.